What's going on? My name is David Brunero, and I will be doing my professional seminar presentation on domestic anthropogenic climate change over the long term. So, what does this mean exactly? First off, why is climate change and engineering technology? Well, first off, climate change was arguably, it could be considered as being caused by engineering technologies. Increased industry leads to increased CO2, increased methane. Those are the greenhouse gases that we see that has, in the ideas of many scientists, caused climate change and is causing climate change to this day. So it is a problem that has been caused by engineering issues and can potentially be fixed by engineering issues. So with that in mind, let's take a look at some of this background. I will be looking at the effects of unchecked climate change, especially greenhouse effects. That is the environmental and social changes that result as a result of not taking any action to mitigate climate change that's already in progress. This presentation investigates the worst case scenario over the course of every 20 years, all the way up to 2100, based on predictions that I've collected in my data. So in general, climate scientists do agree that climate change is anthropogenic, that it is human caused, and is a very emotionally and politically charged issue. So we'll just take a brief overview of some of the technologies and some of the problems that arise from climate change. Okay, how does it relate to engineering? Again, it is a result of increased industrial activity, and climate change is mostly due to increased greenhouse gas levels, which is CO2, carbon dioxide. This accounts for 82% of greenhouse gases, and methane, which only accounts for 9% of greenhouse gases. But due to properties of methane, it will actually trap up to 72 times more heat in the atmosphere than CO2. So the two of these gases combined are what are commonly referred to as greenhouse gases. And modern electricity generation and transportation, which are both engineering technologies that we've developed over the past century or so, account for 70% of domestic CO2 emissions. So what are some of the potential long-term issues with anthropogenic climate change? Well, right off the bat, we've got global warming from greenhouse gases, which in turn leads to ocean acidification and a rise in the oceans due to melting glacial ice caps. And somewhat contrary to this, we will also experience droughts and dust bowls in inland areas. Now that is a result of messing with some of the severe weather patterns that occur. So just because oceans are rising and it's getting warmer, it doesn't mean that we're not going to experience droughts in inland, because those two events are directly linked to each other. Some of the subsequent issues we could see as a result of this are population increase, food shortages, and disease outbreak due to the first two. So those are some of the subsidiary effects that we will see as a result of climate change. So this is a prediction of what the world could look like in 2030 with unmitigated climate change. We are on track to have temperatures risen 1.5 degrees Fahrenheit from the average over the past century. And this in turn will lead to increased rainfall in some areas, changing the weather patterns. And up to 80% of glacial mass could be gone if we do experience a temperature rise of 1.5 degrees, which will put human population under freshwater stress, and that will in turn create a food stress as well. So we do see the population increasing by several billion. That's a projection which could potentially outstrip the carrying capacity of Earth. And all of these effects will result in social effects, basically social unrest as resources become scarcer. So up to 2050, scientists are predicting, some scientists predicting up to 9 billion, some even higher. So as population expands, resources become scarcer. Illnesses get worse due to stronger viruses, which is something that we don't see as a direct result of climate change, but it's one of the trickle-down effects, especially when you talk about resource scarcity. So again, this could cause some drought in the southwest, some of the dust bowls we were talking about earlier, and that social unrest only continues, which could eventually accumulate in a mass migration of the American population. So again, not necessarily one of the issues you would think about with climate change, but when things get bad enough, you do see like a social migration, a mass migration. And one of the ways we can mitigate this is greener technology, less drought, and more opportunity to wherever you can find the most opportunity. By 2070, some scientists predict that sea levels domestically will have risen up to 3 feet. Obviously, this will cause challenges for coastal cities, Miami, New York, some of the others. And we even do see some island nations and American coastlines disappearing with such a great height. We see a massive spike in greenhouse gas in the atmosphere caused by the gases we're talking about, CO2 and methane. Something interesting that is an actual engineering issue, when you do realize a temperature rise of about, I'm not sure the exact degrees, but when we start melting permafrost in the Arctic, then we will release even more CO2 and methane. So once you hit that point of heat, where it gets too hot for permafrost to stay cold, then eventually that will melt and you will release even more CO2 and methane in a negative feedback loop. So by the end of the century, some of the more doomsday scientists are predicting New York being flooded by storms, millions of people being displaced, potentially the grid going down, and industry even grinding to a halt. So what are the steps that we can take to mitigate some of these issues if these are the worst of it? Well, take a look at what could happen in Miami. Again, if a giant hurricane hits Miami as a result of some of the storms that we were talking about earlier, so some of the severe weather, then that's where you see forced immigration, strain on resources, gas lines, and like some of the crime issues that we see, and those are some of the social issues. New York, on the other hand, if we were to experience a rise in green technology, it would be in a big metropolis like New York. So what could New York do to adopt the green technologies that would help prevent some of the things we might see in the rest of the country? Well, green energy in progress. We can see green living in urban areas. You can see rooftop gardens. You can see smart grids. You can see some green technologies, mass transit, composting, and efficient use of municipal waste. These are all really important green technologies that a big metropolis would have to adopt if they were to survive rising climate change issues. Okay, so how do we predict the future exactly? I've got some sources here to show. All this might sound a little bit out there, but when you take a look at the history of our rising temperature, ambient temperature, we can take a look at where we were between now and the last ice age. It was about 4.5 degrees Celsius. So we were only 4.5 degrees Celsius colder than we are now during the major last ice age, like about 20,000 years ago. So where we are today, we're about 1.5 degrees Fahrenheit higher, and scientists predict in about 90 years we'll be almost 5 degrees higher, which whatever the opposite of a glacial ice age would be. That's not something we can really predict, but that's what we have tried to predict in some of these earlier slides. Like this prediction would essentially be the opposite of an ice age, and it could be potentially catastrophic. So this is some data from NASA. This is the NASA Goddard project, when it tracks CO2 levels over the past 400,000 years. They can do that based on ice. What do you call it? You can basically drill into the ice and measure CO2 levels from times up to 400,000 years ago. So right now, for the past however long, CO2 levels have been staying below 300 parts per million. And as of 1950 and between 1950 and now, we've raised almost 100 parts per million to 400 parts per million. So it's a very worrying trend that a lot of climate scientists, they look at this, and that's where we get some of these predictions from. One of the ways to conceptualize the action that has to be taken on climate change is we call this Pascal's wager. Basically, it's you have to think about whether or not we will act on climate change and whether or not climate change is even man-made and preventable. So if you take a look at this, there are 4 different options here. 2 of these outcomes are either economic or environmentally catastrophic, whereas the other 2 options are civilization will continue with basically untouched. So how do we know which of these routes is going to be taken? And essentially we can't. Acting on the assumption that humanity will act and that green technology will be adopted, these are some of the possible solutions that we could take. On an individual level, we can be more environmentally conscious. That's basically recycling, using more efficient light bulbs, adopting efficient mass transits that are currently being built in accordance with green technologies. And governments and organizations, one of the biggest things they can do is they can invest in green technologies. And there are some social policies here as well in terms of international regulations that, while are not related to engineering specifically, still do play an important part in this issue. And again, this is we see the Paris Agreement here and some of the other government actions that have been taken over the years. So what are some of these green technologies that we're talking so much about? These are where the core engineering comes down to it. We've got solar energy arrays, solar water and HVAC heaters for the home, wind generators on a personal level, like in the domestic home, or we could have turbine-like fields, which could also generate energy. And these are some of the up-and-coming green technologies we really want to adopt. Some of the other ones, if you've got less meat demand, you could supplement that with lab-grown meat, and lab-grown meat will dramatically reduce the amount of methane, which is, again, one of the important greenhouse gases. So that would really help. Biofuel, molten salt energy storage, and smart grid technologies are all up-and-coming green technologies that can really affect what we're trying to do here. Sorry, that was backwards. And these are some of my sources. So, thank you. That's the end of the presentation. And do we have any questions?
Yeah. Do you see climate change as more of an engineering or a policy issue?
So the way I think about that is, for us, for the engineers, it has to be an engineering issue. We have to believe that if we put the money and the time into developing green technologies that we have, then eventually the policy changes will change in such a way that they can be readily adopted. And that's really the best that we can hope for at this point. So for us, for the engineers, climate change is definitely an engineering issue, and we have to treat it as such.
Thank you.
Okay, thank you. That's the end of my presentation.